Today we're going to be looking at the next section in our chapter 6, which is over square root functions. We've looked at other types of functions and their graphs, and basically we're just continuing on and adding another type of function kind of to that list of functions that we know and that we know how to graph. So, in general, a square root function is going to have to meet the normal requirements of being a function. So remember that that means that it has to pass my vertical line test, and it's going to have to be continuous. So it is a function. That has the square root of a variable. So it doesn't necessarily just have a square root, because if I have, say, y equals x times the square root of 2, this is not a square root function because my square root is not over the variable. However, if I had something like the square root of 2x, this would be a square root function because my x is included in my square root. Just know that we can see functions with other types of roots, and we'll learn more about those later on in the chapter. So like third roots, fourth roots, things like that. But for right now, we're going to be focusing on square roots. So here's just some general information about our function. So remember that our parent function is going to be the most basic function that we have for that type of function. So in this case, it is f of x equals the square root of x. Notice that our domain is going to be restricted. It's not all real numbers like it was for many of our polynomials. And the reason for this is because, remember, when I'm talking about a function, I'm talking about being in the real numbers. And we learned about complex numbers, but when I'm talking about real numbers, notice that anything that is negative underneath my radical will not work. And so basically we have to restrict our x's to make sure that they are positive. So it's going to be x such that x are greater than or equal to 0. Now, because we had to restrict the domain, notice that if we can't plug in any negatives in there, there's also no way for us to get out any negatives. So we can only plug in positive numbers, and as a consequence of that, we can only get out positive numbers as well. And so that's why there's a restriction on our range, which is f of x such that f of x is greater than or equal to 0. We have intercepts at 0, 0. Notice that it's not defined for anything where x is less than 0. And then the end behavior, notice that it is increasing, so x is going towards positive infinity as f of x goes towards positive infinity. And then because we don't technically have a left-hand side because it stops, basically they just say x goes to 0 as f of x goes to 0 since it stops at that point 0, 0. So, in general, sometimes we might want to identify the domain and range of a function. Now, with my parent function, when I didn't have anything else going on, it was just x is greater than or equal to 0. However, here, notice that we also have a plus 4. So it's not just that x has to be greater than or equal to 0 in this case, because notice that if I plugged in, say, -1, for x, we would get the square root of 3. Now, that's not like a nice, pretty answer, but it does still work. So we know that my domain needs to be adjusted a little bit. And so we can take that same type of idea, and we know that it's whatever's inside of our radical, that's what needs to be positive. And because we have a plus 4 this time, it's not necessarily just the x. It's x plus 4 that has to be greater than or equal to 0. So whatever's on the inside has to be greater than or equal to 0. And then we can just solve like we would a normal inequality. So I'm going to subtract 4 from both sides. And then in this case, that's all there is to do. So I get that x is greater than or equal to 4. So I would say my domain is x such that x is greater than or equal to -4. Now remember that that is our set builder notation. We can also use our interval notation. So remember that I'm going to put a hard bracket because it does have an equal to bar. I'll put -4 and then it goes on forever, so to infinity. Now, it also asks us for our range. So we need to figure out basically what is the smallest value that we can have for f of x. Well, since -4 is going to be the smallest value that we can have for x, if we plug that in for our x value, it will tell us what the smallest output associated with that will be. We'll notice that we get the square root of 0, which equals 0. So we know that our smallest f of x value is going to be 0 still. And because like our parent function, this graph will also be increasing, we know that our f of x's will be getting larger. So we know that f of x has to be greater than or equal to 0. And then again, that is our set builder notation. We can also put it in interval notation instead, and we would put 0 to infinity. And I don't care which notation you use, either set builder or interval, but you do need to use one of those when writing out your answer. Now, just like with some of our other functions, we looked at what the parent graph looks like here. So it kind of looks like a sideways parabola, but it is only half of it because we're only looking at the positive portion. But just like with our other functions, we have transformations that can occur with that. So remember that if I have anything on the inside of my function, which in this case the inside is going to be inside my square root, that's going to act as my h. It's going to move it left and right. But because I already have a negative sign there, remember that it's the opposite direction. Then if I have anything on the outside of my function, it's going to act as my k value, which is going to move it up and down. And then lastly, our a value, which is what's being multiplied to the front, is going to stretch or compress it. And then also, if it's negative, it will also reflect it across my x-axis. So let's go ahead and look at some examples with graphing. So in this case, we have y equals the square root of x minus 2 plus 5. Now just for reference, I'm going to go ahead and start by just graphing my parent function. So remember that our parent function is just y equals the square root of x. And we do want to look at a couple of key points. So notice that if we plug in 0, we get out 0. Now, we could plug in, let's say, 1 next. If we plug in 1, the square root of 1 is 1. And we could keep going. But notice that if I plug in 2, the square root of 2 is not going to be a very pretty number because it's going to give me a decimal. So I'm going to go ahead and skip all the way to 4 because now when I plug in 4, the square root of 4 is 2. So with those 3 points, it's going to give me a pretty good idea of what my function is going to look like. So this is the general shape of our parent function. Now, remember that that's not the function that they asked us to graph. So remember that our minus 2 on the inside is going to move each of our points right 2, because it's the opposite direction of our sign, and then up 5. So I'm going to take each of my points and move them right 2 and up 5. So basically, we've copied and pasted our graph. So that would be what our graph would look like. Now also notice that it asks us for our domain and our range. So remember that in order to find the domain, I would set the inside greater than or equal to 0. So in this case, I know that it's going to be greater than or equal to 2. So we would have 2 to infinity. And then if we wanted to figure out what our y value was, we would plug that 2 back in. Simplify, and we get 5. And notice that our graph is still increasing, so we know that our range will be y is greater than or equal to 5. And that would be my domain or my range. Now let's look at one more example. In this case, they give us negative 2 times the square root of x plus 3 minus 1. So remember, again, I want to start by looking at what my parent function is, which is the square root of x. And again, plugging in kind of those 3 key values. It looks something like that. Except notice this time, the shape of the graph that we're looking at is not just the shape of our normal square root function. Notice that we have an a value, which is negative 2. So I'm going to look at how would that a value affect my graph. Remember that I would still be plugging in the same thing, because that part doesn't change. However, now when we plug in 0, well, the square root of 0 is still 0, times anything is still going to give us 0. So that won't change. But now when we plug in 1, we take the square root of 1, we still get 1, but now we have to multiply that by negative 2. So we get negative 2. Then we plug in 4, the square root of 4 gives us 2, but now we have to multiply that 2 by a negative 2, which gives us negative 4. So whatever our a value is, we will be multiplying that to each of our y values. So notice that our graph has been stretched away from our x-axis, and it has also been reflected across our y-axis. So then lastly, we want to graph our actual given function. So we're going to take each of the points from our green graph, move them left 3 times, and down 1. So our final graph would be there. So then the last thing that we want to find, again, is our domain and our range, and we would do that the same way. I'm going to set my x plus 3 greater than or equal to 0. Remember that it's only the inside stuff that I care about. So I would still have negative 3 to infinity. And then to find our y value, so notice that we would get the square root of 0. The square root of 0 is 0 times anything is still going to be 0. So I get 0 minus 1 gives us negative 1. But we do need to be careful this time because notice as we are going out towards infinity, remember that our blue graph is our final graph. And notice that our function is decreasing. So because we've been reflected, our y values are no longer getting bigger and bigger. They're getting more and more negative. So notice that for our y values, negative 1 is the biggest y value that we could have instead of being the smallest y value we could have. So our interval is going to be flipped, so it's going to be negative infinity to negative 1. Or the other way that we could write that would be f of x such that f of x is less than or equal to negative 1. So just be aware that when we reflect it or have a negative on the outside, it's going to change our range a little bit as